Hi, this is just a personal note to AJ itself to study for the combinatorics class and to look back for the final. Now, here I want to talk about three things. I want to talk about the flow augmenting problem. I want to talk about the transportation problem and the matching problem. Now, in the flow augmenting problem, there are a few things. The first thing you must know is that, I believe, the size of a maximal matching equals the size of a minimum edge cover. So again, the flow augmenting problem is when you have some vertices and you have an A and U Z and they have unlimited flow and you have to connect them through a string to another one. And there are some rules you must remember is that first of all, whatever you do, there is a finite number of applications of the flow augmenting algorithm that yields a maximum flow, and flow would just be the value that can get from A to Z determined by the capacity of these pipes. So one may be 5, one may be 7, one may be 6, one may be 2, and so that pipe would really hinder what could go through this line. Also, something to think of is is that all for the flow? In flows, you're going to have cuts, and the max flow is equal to the min cut. Also, something you want to know is, wow, sorry, I forgot I was doing this video. Why does it just do that? Okay, something you also want to do is the value of any flow is at most the capacity of any cut. And that's it for that. For the matching problem, you want to know that the maximal matching will equal the minimum cover. And knowing this, and this again is the problem I have another tutorial on, where you have the numbers and you try to figure out, selecting which ones would cost the least, but one worker can only work for one store or something like that, or one boy can only have one girlfriend, and you have to figure it out. 2, 3, and then the maximum matching will always equal the minimum cover, and that can be shown right there. Is that not going to correct itself? The minimum cover, and this means that the matching is always less matching is less than or equal to the cover. It can be equal to but never greater than. And then oh yeah, when the matching is saturated, comma, the subset A is, let's see, I need a subset symbol, but I seem to not have one. Let me see if I have one here. I'll just put A of X. Always remember that the cardinality or number of elements in the number of elements in A is greater than the number of elements of its neighbors. So this will be represented as A is greater than R of A. In the transportation problem, I don't know, but here's some tips. If there's a super source, one of the better things to do is, let me try to get rid of all this stuff. Is that if you have multiple sources and sinks, which Shimizono may ask, is that if you have a source here and then he has multiple sources, is to make a super source and then connect them, and thus you can then determine where they go, and these will have infinity capacities, and you can just figure it out from there. Another thing to remember is in the transportation problem, if taking the minimum of two of the costs cancels it out, select one that's special and include that so you can rewrite the prices again when you do the 10-20 thing at the end. I hope you understand this, AJ. And then let's see. Just remember to read maximal versus minimum matching. Remember that if the graph is not directed, that you draw two arrows, 2, 1, so you can go both ways, as that was what's an ungraphed reflex. And remember that if there's arrows coming in and coming out, that you make that into two vertices, BI and BO, and that all the ones going in are into BI, and then you just have one going into BO, and then all those ones are going out, and that will help you figure out that problem. Remember a cut, as in here, a cut is a is a bipartition of vertex sets, and a flow is a function that puts values in the vertices. I don't know if there's anything else. Remember your P to calculate P and P naught, the cuts, which is what you cannot get, which is what on your last application of the flow algorithm, if you can only get to 3 of them, then that's your cut, and that's your P, and that is your P sharp, and that you show those together. Not with this U thing, but you show P and P sharp, which would be that one and that one. Anything else I hope I have gone over? That's about it. And remember that you want to look in the matching problems, you want to look for the Y's. The covers are the found Yodas, but you don't want to find X. You don't want to dig up the buried treasure. So yeah, that's about all it, AJ. Remember that if P is the set of vertices labeled during the final application, then an unsuccessful attempt P/P naught is the minimum AZ cut. And the minimum AZ cut is equal to the maximum flow. Okay, have a good one.